Good afternoon, everyone. Welcome to our presentation. We are Group 36, and this project was done by me, Edward, and my partner, Walter. Today, we're going to showcase our final product of an automatic gardening system. We'll talk about our design process, the mechanics, the algorithm, followed by a quick video demonstration. So for our designing, we wanted to make sure that it has a few features. Firstly, the system is supposed to allow the user to add more water when there's insufficiency. Secondly, we want the spraying spouts to rotate to cover a larger area. Thirdly, we want to use moisture level as a negative feedback. And finally, we wanted to make sure there is communication between the user and the system, which is done through mobile phone via Bluetooth. For equipment, we used Arduino Due board, Bluetooth module, moisture level sensor, motor servo, a buzzer, and a few other components. And here is just a quick look into our algorithm behind the system. We won't go in depth because you will see more in the video demonstration. And let's talk about a few problems we've encountered. Because we were unable to purchase the ultrasound sensor, we had to use infrared sensor instead, so our design needs to be modified to accomplish that. Also, to support the rotating function, it turns out that a bottle of water is quite heavy to spin, so we had to incorporate a bearing to allow smooth rotation. And finally, there is a problem of sealing the whole bottle properly, and we achieved this by using a ton of plasticine and hot glue. In this section of the video, we are going to demonstrate how the system works. The main body of the gardening tool is a double-ended bottle mounted on the supporting framework where Arduino Due and breadboard are attached to. The bottom end is connected to a ping-pong ball where two spouts are placed at 90-degree angles to each other. In order to allow rotations to occur, a sealed bearing was pushed into the bottom end of the bottle in replacement of the original cap. Then we have the motor servo underneath the ping-pong ball to drive the action. Now let's move on to the main features of the system. Firstly, when we detect there is insufficient water remaining in the water tank while the plant has a low moisture level, we want the buzzer alarm to turn on and signal its user to add more water. Here we have a box of dry soil and an empty water tank. As you can see, the infrared sensor lights up the red LED, meaning that it detects the water level mark is sitting at the bottom. This is going to trigger the buzzer alarm to turn on, and the Bluetooth shield will send a message to our mobile phone suggesting current water level is low and please add more water. Here I'm just trying to add some water. As you can see, once the water level is high enough, the red LED will turn off, the buzzer will turn off, and the servo will start to spin. If you pay close attention to the movement, the servo will firstly have a clockwise 60-degree rotation, return to its neutral position, followed by another 60-degree rotation counterclockwise, giving us in total 120-degree range of motion. Just observing. After a few rotations, the moisture level is going to increase. And in our program, we have set the threshold of ideal moisture level at a certain value. Once it reaches that threshold, the moisture sensor will feed back into our Arduino, and the program will send a message to mobile phone via Bluetooth saying that current soil moisture is high and the whole cycle is completed. This process will repeat itself automatically depending on water level and the moisture level detected.